All right, so we're going to be solving rational equations. There's two ways in two cases which we can solve these. In the first type we have here, it's where we have one fraction or one rational expression equal to another rational expression. And if that's the case, we can just go ahead and cross multiply these two. So I can just multiply 7 by x, which would give me 7x. And then that will now be equal to 4 times x minus 6. And then after that, I just go ahead, I simplify and I solve. So then 7x is going to equal 4x minus 24. Subtract 3 from both sides. So then I'll get 3x is going to equal a negative 24. And then once I divide both sides by 3, I'll get x is equal to a negative 8. What is worthwhile now, though, is just plugging in our solution to make sure that we do not get an extraneous solution. And to do that, we really just have to plug it into our denominator. And if I was to plug in negative 8 to either of my denominators here, that would give me a negative 14 and negative 8. So that should work. Examples numbers 2, 3, and 4. These are all examples here where we can go ahead and we can cross multiply. A good one to look at would be like number 6 right here, where again, I'm going to go ahead and I'm going to cross multiply. So then I get 2x minus 3 multiplied by x plus 4, and that is going to equal 6. So when I multiply this together, I'll get 2x squared plus 8x minus 3x minus 12 is equal to 6. And then I can do two things. I can combine these two terms here as well as subtract the 6. So then in total, that would give me 2x squared plus 5x minus 18 is equal to 0. So if I ever get a case where I get a quadratic or something like that, I am going to go ahead and set it equal to 0. And then I'm going to go ahead and I'm going to factor it, and I'll see what two solutions I end up getting. So once I do that, factors of negative 36 that add up to 5, that would be 9 and 4. So let's say x plus 9 and x minus 4, and I'll divide each of those now by 2. So then I will get 2x plus 9 and then x minus 2 is equal to 0. So then I will get two solutions here. I will get either a x is equal to a negative 9 over 2, or I'll also get x is equal to a positive 2. And again, just like in our previous question, let's go ahead and just make sure, because if I was to plug in either of these into my denominator, I would not get 0. So therefore, these two should work as proper solutions. We move on to the next set of type of questions where, in this case, I do not have two fractions equal to each other. On the left side of my equal sign, I have two parts. I have 4/3 minus 7 over n. And on the right side, I just have 1 over 6. So we can condense the left side to go ahead and be one fraction, or we can get all of our denominators to be the same thing. So we'll do one way for one, and then we'll do another way for another question. So in this case right here, I'm just going to condense my left side of my equation to all have the same denominator. So in order to do that, I'll multiply this by n, I'll multiply this by n, and then I'll multiply this by 3, and then this by 3. So on my left side, I will get 4n minus 3 times 7, which is 21, over 3n is equal to 1 over 6. And now this looks similar to one of our previous questions. And so now I'm just going to go ahead, I'm going to cross multiply. So then I will get 6 times 4n minus 21 is equal to 3n. So that would be 24n minus, what is that? 100, nope. Yep, 126 is equal to 3n. And then let's subtract 24. So then negative 126 is going to be equal to a negative 21n. So once I go ahead and I simplify that, I will get n is going to equal a positive 6. Again, you can check for extraneous, but this is going to go ahead and work here as well. And then so in our other type of case, for example, we can go ahead and get all of our denominators to equal the same thing by finding the least common denominator. Let's do that maybe on a question like, let's look at number 8 real quick. Let's do that one first, and then we'll do number 9 after. If I multiply, and I want everything to have the same denominator right here, this needs to be multiplied by 2. This is going to need to be multiplied by k, and then this is going to be multiplied by 2. So when I do that, I will have 6 over 2k minus k, because 1 times k is just going to be k, over 2k is equal to 24 over 2k. And now that all of my fractions have the same denominator, I can just go ahead and set my numerator equal to each other's equation and just solve it as 6 minus k is equal to 24. And just do a couple steps here. I'll get negative k is equal to a positive 18. So then k is going to equal negative 18. And then the last example we're going to do is going to be this one here. Again, whenever we have something that is factorable when given to us as a rational, we want to go ahead and factor it. So I know that p squared minus 4, that's going to be equal to p plus 2 times p minus 2. And I'm going to treat this one as one like we just did, where I get all of my denominators to be equal. So I know that the p divided by p minus 2, that needs a p plus 2 over here. And then I know that 2 needs both the p plus 2 and p minus 2. So I'm just going to multiply that, again, by p squared minus 4, because p squared minus 4 is the same thing as p plus 2 times p minus 2. So I'll multiply my numerator and my denominator by p squared minus 4. So I'm going to have everything multiplied out here. So p times p plus 2 will give me p squared plus 2p. And then I'll have 2 times p squared minus 4. So plus 2p squared minus 8. And that's going to be equal to, I don't have to change anything with the 8, because again, that already has a denominator of p squared minus 4. So that's going to equal 8. And again, each one of these is going to be over p squared minus 4. And then again, since all of my denominators are the same, I can just solve my numerator. So I will just combine now like terms on the left side. So that will give me 3p squared plus 2p minus 8 is equal to 8. So I set that equal to 0. 3p squared plus 2p minus 16 equals 0. And so now I just have to go ahead and factor this. So we're looking for factors of a negative 48 that add up to 2. So that would be, it'd be 6 and 8. So we'll have p plus 8 and p minus 6. Both these now divide them by 3. So I'll have 3p plus 8 and then p minus 2 is equal to 0. So then we'll have p is equal to negative 8 over 3, and we'll have p is equal to a positive 2. Now, again, I should check for extraneous solutions, because plugging in negative 8/3, that will give us a denominator that's not equal to 0. But if I was to plug in 2 back into my original equation here, either here Or here, it would result in 0 in my denominator, so therefore that is not going to be solution. So p is equal to 8 divided by negative 8 divided by 3 will be our only solution in this case. I would say work through the remainder of the questions on these 2 pages, and then check the Canvas page if needed for an answer key.